Hi, my name is Lonnie Clough, and this is my project for GIS 540 to investigate appropriate sites for the National Science Foundation Olympics Radar Observing System. This is my second presentation for the class. The specific purpose of the project is to identify locations in the Olympic Peninsula in the state of Washington near Lake Quinault to place 3 radar systems in a triangular arrangement with minimal blockage, and then a usable GUI will be created for other scientists to use the data. The major overview and why we are doing this project is because the Olympic Peninsula in the state of Washington experiences orographic precipitation within the mountain ranges with precipitation rates of 50 to 70% higher at the crest than annual precipitation means. Current knowledge of orographic precipitation is greatly limited by the lack of large rain gauge and radar networks with the ability to monitor small-scale precipitation events. Radar antennas, furthermore, are difficult to place in mountains due to topographic features which can block radar beam patterns. This tool identifies appropriate sites with minimal blockage for placing the National Science Foundation's Olympics Radar Observing System in Washington's Olympic Peninsula. So my code has 7 steps. First, all the libraries are imported and the system is set up to run. Then all of the spatial projections of the file are checked to make sure they're correct and in the right folder. If they're not correct, they're projected and put in the correct folder. Then, to speed up the processing, because all of the shapefiles are for the entire state of Washington, and this is actually a relatively small area, a buffer is created around the lake to isolate the areas and all of the shapefiles that are around the lake. It makes the code run much faster. Then there's a search for points which fit into our criteria, such as they're close to a road, not on an active fault, etc. A viewshed analysis performs. The best points are found according to how much they can see from the viewshed analysis, and they must be in a triangular formation. And then a GIS map is created. So I'm going to show you how it runs right now. So here's the map, and you can see over here is my tool button, and I'm going to press it. It runs very quickly because I have it buffered. So here, and it's also set up so you can just press OK and it will run with all the defaults. So this first one is just where you set up where your data is located. This one is just an empty folder which you'll use to store all of the files that are created during this process. Here are constraints so that you can say, I don't want my systems to be on any active faults or rivers or landslides, etc. Here's the buffer, so you can choose how much of the area you want to buffer around the lake to either make your area larger or smaller. And then the base of all the files are on clear-cut forest. So these are fields that just choose all the clear-cut forested areas. And then this is a buffer to choose how close you want to be to the road. You want your sites to the road. You can choose the height of the height of your equipment, the maximum, minimum that your angles that your radars will scan at, and then also you'll save your data in another map. And then you can also save an image. So I'm going to run it. It runs very quickly in about 30 seconds. Here it's running. It's already checked all the spatial references, buffered all the data, and now it's trying to look for the different sites. And next it will start running the viewshed analysis. It's done that, and now it's trying to find the sites with the best coverage, and they must be in a triangular formation. And then it's finished, and it says analysis is completed, open the other map to see your results. And I did this so that you could work on this map however you wanted and then save the results in another map. And so this is what it will look like. This is your final project, or your final result. Well, thank you very much.